So here is an example of deriving the rotation matrix from a problem specification. So we have here two frames, the red frame and the blue frame. Okay, red frame is frame number 0 and the blue frame is frame number 1. We can go from the red frame to the blue frame by rotating about the x-axis by 90 degrees or pi over 2. Okay, so we would like to derive the rotation matrix that takes a vector in 1 and represent it in frame 0. So we would like to have R from 1 to 0. Okay, so and this is equal to, okay, the projections of frame 1 coordinates into frame 0 coordinates. So now you see that the x-axis of frame 1 is completely parallel to the x-axis of frame 0. So it is, they are equal, in fact. So your the projection here is simply the x-axis, the I-axis. Okay, it's the x-axis of frame 0 itself. Okay, now for the y-axis of frame 1, you can see that it is in the direction of the z0 axis. So it equals the z0 axis, which is 0, 0, 1. Okay, this is the z-axis in frame represented in frame 0. Okay, and for the z-axis in frame 1, okay, you can see that it equals it is equal to the y-axis of frame 0, but it is in the opposite direction. It is parallel to the y-axis in frame 0, but it is in the opposite direction. So we multiply y0 by -1 and then list the components here. So y0 is nothing but 0, 1, 0, but it is in the negative y direction, so there is a minus sign here. And this is the rotation matrix taking a vector in frame 1 and representing it in frame 0. So if you have a vector in frame 1, okay, some vector in frame 1, okay, let's say, let's call it 1, okay, and you pre-multiply this vector by the matrix R 1 to 0, you'll get this vector represented in frame 0. Okay.